Assalamualaikum. My name is One Asal Fajra dan Tuan Aziz. Nama is 202188642. And today I will present about chapter 1 introduction of the group of the ITT640. First of all, I will present about the company organization. The organization operates from a three-installment of the design for single functionality across the various departments. On the second floor, the administrative office oversees daily operation which a team interprets into the account management and administrative staff. The finance office also on its floor employs 15 workers to handle information activities. The first floor hosts the information technology which is IT department, which have a team specialized maintaining the tech infrastructure and the research and development R&D department where five engineers focus on product innovation. The ground floor is bustling with the shipping or receiving department which manage a goods movement which sits employed and the manufacturing department which has 10 staff overseeing production. This floor also includes a conference and training room and also the same department comprising 10 professional driving revenue. Each floor is equipped with a wiring closet connected by a fiber to ensure seamless communication and data flow throughout the building. Next, for the project diagram, the project main goal is to establish a comprehensive wireless network for the company's three-story building using advanced simulation tool or network diagram tool. This includes a full detailed and clear network diagram with effective communication among administrators, analyze the wireless technology to be integrated and making informed decisions on hardware placement, device selection, and network topology. The project involved develop an active address strategy with precise subnet calculation to optimize performance and management. In addition, analysis of user and simulation wireless strategy will be included in the report. After that, result and analysis will execute after simulation has been explained. It also identifies and establishes relevant wireless standards, ensure a robust, secure, and scalable network that meets current needs and adapt to future growth. Next, problem statement. The company understood action of non-organized wireless network architecture create considerable hurdles, resulting in connectivity constraints and poor communication between divisions. The absence of cohesive network architecture complicates network device and administration and troubleshoot, leading to operational inefficiency and potential security concerns. There is an urgent need for a well-designed wireless network that tackles this concern, notably in terms of offering unique network channel and SSID to improve security and avoid interference. This situation aggravated by the lack of separate gas network, which jeopardized the company's critical data and network security. This project intends to address the essential challenge by creating a comprehensive wireless network that provides a seamless connectivity, strong security, and easier administrative administration. By resolving this issue, the organization can increase operational efficiency, ensure consistent communication between departments, and provide a safe network environment for both employees and staff. So the project objective. The project objective is to establish a robust and secure wireless network for the company's three-star main building. So, the key objective is to optimize a wireless network such as strategic establishment of wireless access points to minimize overlap and interference. Second, to develop a comprehensive documentation of network design plans, including certificates for each wireless access point. Third, to establish a secure address network which a unique SSID to also adjust access from the primary network and enhance overall network security. The project significance. The significance of this project is to improve the company operational efficiency and communication infrastructure by implementing a well-designed wireless network. The structure and a good network will allow for easy data flow, reliable connectivity across all departments, and secure access for employees and users. This project will result in scalable and maintainable wireless that not only meet current operating needs but also accumulate future expansion and technological development, but address a security concern through establishment of unique network channel and SSMD. The project will reduce the risk of unwanted access and network interference for the company critical data. The detailed documentation of the network architecture will be an invaluable resources for ongoing network management, troubleshoot and future enhancement ensure that the network remains efficient, secure, and productive. Finally, this project will help the company technical grow, increase overall productivity, and support its strategic goals by offering a dependable and secure wireless network infrastructure. Review of the VLAN technology. So I will present a brief description for each connectivity topology, protocol, and also quality of service. For the connectivity, advancement in ITT is 802.11 standards such as Wi-Fi 5 and also Wi-Fi 6 have enhanced a Wi-Fi connectivity by increasing speed and introducing features like MIMO, catering to diverse network needs and environmental challenges. Topology range from the control connectivity of the basic service set (BSS) and infrastructure mode to the expansive coverage and seamless roaming capability of the extended service ESS and resilient harmless basic service set in ESS network in dynamic and complex environment. Protocol. The protocol covered include CSMA/CA for managed data collision in wireless network, TCP/IP for multi-data packet and assigned IP address, and CP and UDP at the transport layer for reliable and fast communication respectively. Quality of service. Quality of service and wireless network ensure consistent bandwidth distribution for the same type of traffic, prioritize the critical application and enforce and reduce minimum latency and jitter, thus enhance overall network performance and user experience. Connectivity. Advancement in IEEE 802.11 standard from older version like 802.11b or 09 in the 2.4 GHz band to the latest techniques Wi-Fi should utilize 5 GHz as revolution Wi-Fi networking. This advancement has significantly boosted speed and efficiency, which Wi-Fi 6 introduced services like MIMO for handling multiple devices simultaneously in busy environments. Just between 2.4 GHz and 5 GHz band depend on coverage need versus speed, which 2.4 GHz becomes a better range that has susceptibility to interference, while 5 GHz provide a faster speed but limited range and sensitivity to obstacles. Actual Wi-Fi speed can vary, directly due to factors like distance, obstruction, interference, and also network congestion. Security protocol has evolved from WEP to WPA3, enhance the protection for sensitive data. Understanding this element is crucial for optimal Wi-Fi performance and also ensure secure and reliable connectivity. Technology. The wireless network technology offers a versatile design tailored to specific networking needs. The basic service set ESS and infrastructure connect devices through a access point AP, ensure a compatibility and enhance security. Suitable for the retail, for residential and business network. Independent service set IDSS of the utmost facilitate direct device-to-device connection with the AP, ideal for temporary and more decentralized external service set ESS integrate a multi-party under one SSID enable a seamless roaming in expensive area like office building and also public venue. Mesh network with a mesh basic service set MESS enhance availability with dynamic routing and fast healing capability. crucial for large and complex environments. Point-to-point and point-to-multipoint topology caters to diverse connectivity from long-distance to synchronous management of multiple devices, showcase a wireless network stability across a variety of critical applications. Second, the media access control net layer in wireless sensor network WSN manage access to the communication media. Employ protocol like sharing sense multiple access with collision avoidance (CSMA) to minimize the collision during data transmission. CSMA involves not sensing the carrier before transmitting, utilize a random band of delays to mitigate the channel congestion and collision risk, particularly in the environment with data aggre- aggregation or multimedia transmission. A recent advancement includes smart CSMAs, which is LCSMA integrates a learning algorithm to further enhance collision avoidance and network efficiency. Meanwhile, the TCP/IP protocol should operate at network layer, facilitate the IP address assignment throughout the BHCP and enable a communication by mapping IP address to a MAC address via ARP. Transport layer protocols such as TCP ensure relevant data delivery is acknowledged and the transmission while UDP prioritizes speed, making it suitable for real-time applications like VoIP. Application protocol HTTP and FTP will often use transport layer service catering to different needs from a web browsing to file transfer with ongoing development like a dash aimed at optimized media streaming quality over available network conditions. Quality of service. Wi-Fi multimedia doubled and implied enhanced distributed channel access (EDCA) to prioritize voice, video, and data traffic in 6.0 to the 11 wireless line ensure that critical applications receive adequate bandwidth to minimum latency and jitter, thereby enhance overall network performance. Load balancing is crucial in managing network resources efficiently, particularly in EIP environments where energy conservation is paramount. Dynamic energy efficient load balancing (DEELB) strategy have been shown to effectively distribute network traffic and optimize bandwidth utilization compared to traditional methods. Advancing digital management is better for real-time applications like phone and video, which various traffic management algorithms propose for body sensor network (USM) and wireless storage areas this work to improve a throughput, bandwidth, efficiency, and overall quality of service. This investment underscores the importance of optimizing traffic management to ensure the reliable and efficient communication in wireless network.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nashira Dana Bita Mafuad and my student ID number is 2021610142. I will present for review of hardware for wireless line. Firstly is access point. Access point provide wireless connectivity by linking device to a wired network, facilitating wireless communication and extending network coverage. Next is switches. Switches connect multiple devices within a network, managing data traffic to ensure efficient and secure communication between devices. Routers direct data packets between different networks, managing traffic and enabling devices to access the internet or other networks securely. Antennas transmit and receive radio waves, enhancing signal strength and coverage for wireless communication. Network interface card. Network interface card facilitate the connection of device to a network, enabling data transfer and communication between computers and network infrastructure. Next is access point. Access point standalone versus controller based access point. Access point standalone access point function independently, making them suitable for smaller network where centralized management isn't necessary. They are required individual configuration. In contrast, controller-based Access points are centrally managed through a network controller, which simplify managing multiple access points in largest network. This centralized control provide features like load balancing, seamless roaming, and coordinate RF management, enhancing overall performance and reliability. Next is advanced features. Advanced features such as modern AP support dual band operation, allowing them to function on both 2.4 GHz and 5 GHz frequency. This flexibility reduces interference and congestions. MIMO, multiple input, multiple output technology increase data throughput by using multiple antennas for transmission and reception. Beamforming enhance signal strength by directing the wireless signal towards specific device rather than broadcasting in all directions. Next is deployment consideration. The placement of access point is crucial for optimal coverage and performance. Power over Ethernet simplifies installation by allowing AP to receive power and data through a single Ethernet cable, reducing infrastructure cost and complexity. Next is switches. Managed versus unmanaged switches. Managed switches provide extensive configuration capabilities essential for optimizing performance in complex environments like enterprise. They allow remote monitoring and advanced management features, and managed switches offer basic connectivity without configuration options, suitable for simple setup. Smart managed switches provide middle ground, offering some management features at a lower cost, ideal for small businesses. Next is key features. Key features VLAN support allow network segmentation, enhancing security and performance by accelerating traffic. Port aggregation combines multiple connections to increase bandwidth and provide redundancy. Quality of service prioritize network traffic, ensuring critical applications like VoIP and video conference maintain high performance. Lastly is scalability. Stackable and modular switches are designed for network growth. Stackable switches can be connected and managed as a single entity, while modular switches offer flexibility to interchangeable modules, allowing for easy expansion and customization as network needs evolve. Next is routers. Home versus business routers. Business routers have greater processing power and advanced security features to handle complex networking needs and large volumes of traffic. They are designed for environments with many connected devices and higher security requirements. Routing protocols (RIP) is simple but not effective for large networks due to limited hop counts and slower convergence. OSPF, Open Shortest Path, first is more suitable for enterprise, offering faster convergence and better scalability. BGP, Border Gateway Protocol, is used for data exchange between different networks or autonomous systems, essential for large-scale internet routing. Next is security. Features like VPN support and firewalls are crucial for network protection. VPNs secure remote access, while firewall prevent unauthorized access and protect against cyber threats. Next is antennas. Type of antennas. Omnidirectional antennas provide uniform coverage in all directions, suitable for areas requiring broad coverage. Directional antennas focus energy in specific direction, increasing gain and reducing interference, ideal for point-to-point communication. Sector antennas are used in cellular network to divide coverage areas into sectors, improving capacity and reducing interference. Next is antenna gain. Higher gain antennas improve signal strength and coverage over longer distance, but they require precise alignment and positioning to maximize performance. Lastly is deployment consideration. Proper placements and orientation of antennas are vital for optimal performance, ensuring coverage is maximized and interference is minimized. And lastly is network interface card (NIC). Internal versus external NIC. Internet NIC are integrated into the computer, usually connected via the motherboard or expansion slots, providing stable connectivity. External NICs connect via USB or other ports, offering flexibility and ease of upgrades, especially useful for portable devices like laptops. Next is speed and compatibility. Modern NICs support high data transfer rates from 100 Mbps to 10 Gbps, ensuring compatibility with various systems and enhancing network performance. MIMO support further boost throughput by handling multiple data streams simultaneously. Lastly is driver updates. Regular updates are crucial for optimizing an IC performance, ensuring compatibility with new hardware and software, and maintaining security. Updates can also reduce new features and fix bugs, contributing to overall network stability and efficiency. Next, I will present about review of software for wireless LAN. There are a few software such as network management software. The function is to monitor and manage network device and configurations, providing real-time insight and optimizing network performance. Next software is security software, protects networks and devices from unauthorized access and cyber threats using firewalls, anti-malware, and anti-spyware tools. Next is network access control (NAC), secures network access by authenticating device and enforcing policies to ensure only authorized user can and device connect. Next is performance optimization software, enhance network performance by managing resources, analyzing traffic, and diagnosing connectivity issues to minimize latency and maximize throughput. Network management software. The functionality it enables monitoring, managing, and maintaining network device, optimizing operations, and reducing downtime. The key features is network monitoring, configuration management, and firmware updates. Tools like SolarWinds and Cisco Prime facilitate these functions. The benefits is real-time insight into network operation and centralized control for firmware updates. This software is essential for overseeing and controlling network device. It provides administrator with real-time data and alerts about network performance, helping to detect issues early by managing configurations and updates. It optimizes network operations, reduce downtime, and ensure that all devices are working efficiently. Next software is security software. The components are firewall, anti-malware, and anti-spyware tools. Protect against unauthorized access and cyber threat. Types of firewall. Packet filtering firewall operate at the network layer, while stateful inspection firewalls track active connection for enhanced security. The importance of security software is regular updates for anti-malware and anti-spyware are crucial to defend against evolving threats. Security software plays a critical role in safeguarding networks against cyber threats such as virus, malware, and unauthorized access. It includes firewall that filter traffic and anti-malware tools that detect and remove harmful software. This software ensures that sensitive data remains secure and helps maintain the integrity of the network. Next is network access control (NAC). The purpose of NAC is to ensure only authenticated device access the network using standard like IEEE 802.1x and radius. Next is authentication methods. EAP, TLS, and PEAP provide secure authentication through encrypted tunnels and certificates. Next is for policy enforcement purpose. Dynamically applies rules based on real-time data, enhancing network security. NAC solutions are vital for controlling who can access a network. They authenticate device and user before granting access using protocols like IEEE 802.1x and radius. By enforcing security policies, NAC ensure that only compliant and authorized device can connect, enhancing overall network security and preventing potential breach. Last is performance optimization software. The function is manage network resources, enhancing performance and minimizing latency. The key tools is bandwidth management, PTS, MEC, network analyzer, Wireshark, and diagnostic tools, being traceroute. The benefit is ensure low latency, identifies performance bottlenecks, and provide insight into network traffic. These softwares focus on improving network performance by managing bandwidth, analyzing traffic, and diagnosing connectivity issues. Tools like Wireshark help administrators monitor data flow and identify bottlenecks. By optimizing resources allocation, this software minimize latency and ensure that the network operates at peak efficiency, providing a seamless experience for users.
Okay, next I will explain about the emerging trends in wireless local area network. Wireless local area networks are evolving with new trends like Wi-Fi 6 and Wi-Fi 7, offering improved functionality and security. AI and machine learning are used for intelligent network management, threat identification, and real-time responses. WPA3 enhances security, while IoT devices demand more resilient and scalable wireless local area network infrastructures. Okay, there are three main points that we will discuss in this topic, which Wi-Fi 6 and Wi-Fi 6E security enhancements and future technology. Firstly, I will explain about the Wi-Fi 6 and Wi-Fi 6E development in wireless local area network technology. There are a few key features which are firstly orthogonal frequency division multiple access, also known as OFDMA, improve channel utilization and reduce latency in Wi-Fi 6, and also multi-user several input, multiple output, MIMO, for increased network capacity and efficient resource utilization are used in both Wi-Fi 6 and Wi-Fi 6E. Okay, next, it also has a target wait time (TWT) for optimized power consumption and battery life. It is also ideal for environments requiring robust high-performance wireless connectivity and various settings including homes, office, public venues, and industrial facilities. Okay, next, about the security enhancements. The advancement of wireless security standard is critical in the face of increasing cyber threats. WPA3 Wi-Fi protected access 3 was introduced by the Wi-Fi Alliance in 2018. Is a substantial improvement over WPA2. It uses a more secure handshake protocol called simultaneous authentication of equals (SAE), which replaces the pre-shared key (PSK) mechanism used in WPA2. And the advancements of WPA3's encryption and encoding method prove its ability to deliver a higher security level to both personal and enterprise users. Lastly, for the future technologies, Wi-Fi 7 and 6G networks are expected to revolutionize wireless local area networks with enhanced speed, reduced latency, and efficiency. And also, Wi-Fi 7 are expected to use advanced technology like multi-link operation and 320 MHz channel bandwidth, which enabling the high demand application like virtual reality, VR, and augmented reality, AR. And lastly, for 6G network are expected to follow 5G, offer exceptional speed, lower latency, and improved efficiency, and enhancing seamless connectivity for transmission and low latency communication.
My name is Nusra Adam Salim and I will continue the presentation with network requirements. For all the level in the buildings, the signal strength at least negative 65.0 dBm, the signal to noise ratio at least 15.0 decibel, the data rate at least 15 megabit per second, ping round trip time at most 150 millisecond, and the packet loss at most 5%. For different level in the building, they have the different number of minimum access point, which are six for ground floor, four for first floor, and six for the second floor. It is because there are different number of people there, and there are different department for each floor. For the ground floor, there are shipping, manufacturing, conference room, and sales department. And for the first floor, it is IT and R&D department, and the second floor, which is the admin and the finance department. Each floor use a different application, and they do different things. Okay, next, the capacity for each floor. For ground floor, there are 47 laptop, 50 smartphone, and 30 tablet. The number of person that are on the ground floor is 26 employee, and there will be many more people as they are conference room. And for the first floor, there are 15 laptop,
15 smartphone and 8 tablet, as there are only 8 employee. And for the second floor, there are 30 laptop, 35 smartphone and 20 tablet. So the requirement for the access point is suitable for the number of device for each floor.
Assalamualaikum, my name is Nur Ashifah Osman. Let's look at the signal strength and coverage across all floors. On the ground floor, most areas like workspaces, meeting room, and the prayer room have strong signal in green, showing good access point placement for reliable Wi-Fi. But there are weak signal spots in toilets and one small working room marked in red, probably due to walls blocking signals. Moving to the first floor, key areas like workspaces and meeting rooms are all covered in green, ensuring good connectivity. However, there are red zones in toilets and private rooms with weaker signals, likely due to building layout. And on the second floor, most areas show strong green signal, supporting both public and private spaces as well. However, there's a red area in the toilet indicating weaker signal too. Now, let's talk about the signal to ratio SNR across all the floor. On the ground floor, most areas have strong SNR in green, meaning little interference and strong signals. But some spots like toilets and corridor show lighter green, suggesting possible interference. Moving to the first floor, main work areas and boardrooms have good SNR in green, ensuring the clear communication. However, in private rooms and toilets have weaker SNR in yellowish green and orange, indicating weaker signals compared to background noise. Finally, on the second floor, key areas like workspaces and meeting rooms maintain strong SNR in green, crucial for stable connection, but toilets show poor SNR in shades of orange and yellow, suggesting a need for better signal in those areas. So now we continue with network performance. For the first one is throughput. On the ground floor, our throughput map indicates a consistently strong signal throughout the area. The highest signal strength recorded is 110 Mbps and the lowest is 108 Mbps. This uniform high throughput is represented by a dark green coloration on the map, showing excellent network performance and minimal signal drop off across the ground floor. Moving on the first floor, we observe the strongest signal near the router at 110 Mbps. However, as we move away from the router, especially toward the toilet area, the signal strength drops significantly to 26 Mbps. This area represents the weakest coverage on the first floor, indicating a need for potential signal boosters or additional access points to enhance the coverage. Lastly, on the second floor, the throughput map reveals the strongest signal again near the router at 110 Mbps. Similar to the first floor, the weakest signal is found in the toilet area with a recorded strength of 38 Mbps. This reflects the lowest coverage on this floor, suggesting a need for improvement in signal distribution to ensure the better connectivity throughout the second floor. This is the bandwidth map for each floor. Starting with the ground floor, the bandwidth map shows the entire area covered in green. This indicates a uniform but weak bandwidth signal across the floor. While the signal is consistent, it highlights a potential area for improvement in terms of network strength. Moving up to the first floor, the map shows a predominantly green area, suggesting consistent signal strength. However, there is a small white section that indicates slightly weaker coverage. Overall, the signal remains fairly stable but could benefit from enhancement in these weaker spots. On the second floor, we see a similar pattern with more screenly coverage and a minor white area that signals weaker bandwidth. This consistent green signal throughout the building points to basic coverage but highlights the need for further network improvement to address the weak points. These are the map for channel overlap map. On the ground floor, the channel overlap map shows the area is mostly orange, which indicates average channel overlap. The toilet area stands out in yellow and green, meaning there are no overlapping channels there. For the first floor, the map indicates the entire area is orange, reflecting average channel overlap. Interestingly, the store area is green and the toilet is yellow, which means there is a variation in channel overlap levels. On the second floor, the map shows the entire area in orange, similar to the other floor. However, the toilet area is marked with green and yellow, indicating different degrees of overlap and highlighting areas where the network could be optimized further. Now we are at the latency. Looking at the response in ground floor, average with 36 milliseconds. This rapid response time suggests that the network is performing well, with data traveling efficiently between devices, ensuring smooth and stable connectivity. On the first floor, the average response is even faster, at 34 milliseconds. This slight improvement over the ground floor indicates a good network connection with minimal delays, making for a highly reliable network performance. However, on the second floor, the average response time increased to 75 milliseconds. While this indicates a longer time for data to travel, the connection remains stable. Although the network here is slower, it still ensures that no data is being lost. Now, for the packet loss, by examining the ping test, a host on the ground floor successfully pinged a host on the second floor with no packet loss. This shows a stable and reliable connection, indicating that uh, all data packets are successfully sent and received. So it's ensure that seamless communication between the floor. For the first floor, it's also similar that a host on the first floor can ping a host on the second floor without any packet loss. This means that the network connection is very reliable on this floor too. With no data packet being dropped, it ensures consistent and dependable connectivity. Uh, Lastly, despite experiencing a longer response time, a host on the second floor successfully pinged a host on the ground floor with no packet loss. This result indicates that while the connection might be slower, it remains stable and no data is being lost, maintaining a reliable network connection.
Okay, now I will explain on this logical network diagram. Okay, this diagram illustrates a network topology that employs VLANs for efficient traffic management and segmentation. The core router connects the internal network to the cloud, providing internet access and external communication. Okay, the network divided into three VLANs, which are VLAN 10 on the green section, VLAN 20 on the yellow section, and VLAN 30 on the pink section. Each VLAN contain various devices such as laptops, desktop, and smart devices connected through the access point that which is which are labeled as A1 and A2. Okay, this segmentation allows for better traffic isolation and control within each VLAN. A central switch connects all the VLANs to facilitate efficient communication and data flow across the network. The access points in each VLAN extend the network to reach and manage device connections to ensure a well-organized and secure network structure. And now we're going to move on to the access point information.
These tables details the specification of two Cisco AeroNet access point. Okay, the first access point named Net Reaches operates on channel 1, 6, and 11 and supports up to 15 clients with a speed of 10 Mbps using the 802.11 standard. It provides authentication and security through AES for WPA2 and 802.1x radius. The access point runs on Cisco Unified Wireless Network software and Cisco Mobility, supporting both 2.4 GHz and 5 GHz frequencies with a range of 100 meters and an IP address of 202.184.229.8. Okay, and the second access point, as we can see on the right table, is named Guest, has similar specification but operates only on channel 1. It also supports up to 50 clients with a speed of 10 Mbps using the 802.11b standard. The security features, software, frequency support, range, and IP address are identical to the NetReaches access point. Both access point ensure the network security within the specified ranges.
Okay, now this is the simulation for the network topology. Okay, first we are going to open laptop A2 and we will check the IP address for the laptop, which we using ipconfig, and the IP is 192.168.10 and dot 11, and then we ping the gateway, which is 192.168.10.1, and then we ping another VLAN, another device on another VLAN, which is 192.168.20 and 21, and then we ping to another VLAN to check the connectivity to VLAN 30 192.168.30.32, and then we check the device in another VLAN. Okay, on VLAN 20 we choose B6 laptop, and then we do the same thing, ipconfig to check the IP address for the device, and then ping device on another VLAN. So for first we check for VLAN, first we check ping the gateway to check the connectivity, and then we check the connectivity between VLAN 20 and VLAN 10. So okay, we wait until the process is done. Okay, and then we ping to device in VLAN 30 192.168.30.33. Okay, next we check for connectivity in VLAN 30 to the other VLAN. We choose laptop C7, and first we ipconfig, okay, check the IP address, and then ping the gateway 30.1. Okay, there's connectivity between the device and the gateway. Okay, next ping end device in other VLAN. First we check with device in VLAN 10, and then we check with the end device in VLAN 20. Okay, so now we can see that the connectivity is fine for VLAN 10, VLAN 20, and VLAN 30. Okay, now we check for laptop guest. Okay, the IP address is there, 192.168.5.8, and then we have ping the gateway, and now we will ping to another VLAN, which is VLAN 20 and VLAN 30. It must be destination host unreachable, as we already configure the ACL for for guests only, so it cannot connect to the device for the company. Okay, that's all from me. Thank you.
Now I will present about Chapter 5 Recommendation and Conclusions. For recommendation to improve network efficiency and security, a multi-phase approach that combines modern hardware and robust software solution is advised. Upgrade the network interface stack (NIC) to a more recent model with 6-bit capability and also multi-input, multi-output NIMO compatibility can greatly enhance the data transfer rate and reliability. Furthermore, deploying a sophisticated network management tools such as SolarWind, and Cisco Prime can improve network performance by enabling real-time monitoring, configuration management, and also automated firmware updates. Furthermore, investing in cutting-edge security software such as firewall, anti-malware, and anti-spyware programs is critical for protecting against emerging cyber threats. Network access control and issue solutions such as IEEE 8021X and Radius should be used to ensure that only authentication device can connect to the network, improving the overall security and operational efficiency. All software and hardware components must be updated on a regular basis to preserve compatibility, performance, and security into the rapidly changing digital environment. Conclusion: the objective is achieved. In conclusion, we say network enhancement has effectively achieved the major goal of increasing capacity and improving performance. It has allowed us to handle a substantially higher number of remote users while ensuring that the data delay, which previously hampered China's performance, are now completely eliminated. This success not only improves internal communication and operation, but also benefits external stakeholders such as tourists and clients. The availability of dedicated additional network for external users has resulted in significant increase in their connectivity experience, allowing them to access resources effortlessly and dependably. The organization achieved its goal of developing a strong and dependable network infrastructure by addressing both internet and external connectivity requirements. This change demonstrates a strong commitment to sustaining a high level of network stability and user satisfaction. In doing so, the corporation not only fulfilled but also achieved its goal, established a new standard for network performance and accessibility. This proactive strategy demonstrates the company's commitment to creating an efficient, user-friendly network environment that caters to the unique needs of our customers.